Okay. Good morning. Welcome to today's class. Today we are looking at vectors. So, a vector quantity is a quantity that has both magnitude and direction. Examples: displacement, velocity, force, and acceleration. Then scalar quantity. Scalar quantity, that's a quantity that has only magnitude without direction. E.g., instead of displacement, the scalar equivalent is distance. Instead of velocity, the scalar equivalent is speed, mass, and so on. Vector algebra. So how do we manipulate several vectors? That is the concept of vector algebra. So some things you need to understand in vector algebra. 1. Two vectors A and B are equal if they have the same magnitude and directions, regardless of the position of the initial points. So for two vectors to be the same, two things must be equal. The magnitude and the directions must be equal. If the directions are the same but different magnitude, the vectors are said to be parallel. So next, terminology. So A equals to B, yeah? So true. A vector having direction opposite to that of a vector A, but having the same magnitude is denoted as minus A. What are we saying here? Let's say vector A is going this way, vector A. We now have another vector that has the same magnitude and direction as A, but in the opposite direction. Oh, sorry, having the same magnitude, but in opposite direction. Such a vector will be negative of the initial vector. So in vectors, when there is change in direction, will indicate with a negative sign. Next terminology. Sum of vectors. Sum or resultant of vectors. And this is where the real work starts. So let's say we have two vectors, A and B. To add the two vectors, take note, this is very, very important. To add the two vectors vectorially, you choose a starting point, let's call it the origin. Start from any one. Draw the first vector, let's say A, where the first vector stops. Start this next vector. So add B. The resultant of the two vectors is the vector joining the origin to the end of the last vector. So the resultant of these vectors here, let's call it R, so that you know we are talking about resultant. So the resultant of R here is A plus B. Depending on the examiner, some examiners don't use arrow to indicate vectors, but some do use arrows. So it depends on who the examiner is or the textbook being used. So the vector sum of A and B, start from the origin, draw A, where A stops, draw B. So the resultant is vector from the origin to the end of the final vector. Now, what if we had started from B? Are we going to get the same thing? So let's say origin O. So if I started from B, B in this case was horizontal. Now, where B stops, add A. So let's add A. So the resultant is the vector that joins the origin to the final point. And what do you notice? It's the same thing. Our vector R, our vector R. So any which way you go, the resultant here, so in this case this is B plus A, is the same as A plus B. And here we say the vector sum is commutative. The direction of the vector does not matter.